I bought this broken Xbox One controller off of eBay, and I wanted to see if I could fix it. All of the buttons work fine, except for the left trigger and the left stick. The left trigger seems to be stuck at 100%, and the left stick is stuck to the left. Now, like, when I move the stick around and upwards, it sort of affects the trigger, which is kind of strange. So on this controller, the board that the sticks are on is separate from the board with all the buttons and stuff. So I'm just replacing the stick board from the bad controller with one from one of my good controllers, just to rule out anything else. And it seems like everything's working, so there's definitely something going wrong with the board where the sticks are located. So if I look at my good controller towards the left trigger area, the trigger has a magnet in it, and every time the trigger is pressed and it gets closer to that little black component there, it sort of detects the magnetic field and tells the controller that the trigger is actually being pressed. This is the same area under a microscope, and here's the area on the faulty controller. And the black component, which is a Hall effect sensor, is completely missing because I removed it. Because before I decided that I wanted to make a video about this, I cleaned it up because this is what it looked like. So I think the person who sold me this controller must have tried to replace the joystick and probably had their iron too hot and burnt off a bunch of pads and moved around a bunch of components, because if you couldn't tell, there's also a little capacitor missing, which I'm just going to have to hope that that's not required. So the first thing I'm going to do is try and solder this sensor in place and run a wire from this pin to this pad and from this pin to wherever it needs to go, but we'll figure that out later. It's always a good idea to use some form of flux when you're soldering, so I'm just using my flux pen here. It just helps everything flow better. And here I'm just adding some solder to the pads. This ground pad here was kind of a pain because the pad's kind of destroyed, but I managed to get some solder to flow onto it pretty nicely, actually. Okay. Well, so what I should have done here initially was use my tweezers to push down on the component as I'm trying to solder it in place rather than pushing up on it, which I do figure out eventually, but it's still very painful to watch. It looks a little burnt, but most of that is just the flux. And I also couldn't quite get it to sit flush with the board with that pad being raised up as it was. And before I attach the wires, I'm just going to add a little bit of solder to these pins. So for all my wiring in this project, I'll be using 0.1 millimeter enameled copper wire, and this wire has a layer of insulation. And throughout this project, I'm using the method of scraping it off with an X-Acto knife, but Probably the best method, which I didn't learn until way later after I was finished with this, is just using the heat of the soldering iron itself to just melt that layer of insulation away. And that would have saved me quite a bit of time. Okay. And then I'm using my multimeter on continuity mode just to make sure everything's making a proper connection. And then I actually decided that I didn't like the way that this looks, so I just touch it up a bit and remove the excess. I had accidentally gotten this blob of solder on this piece of the board where the solder mask had been scraped off, so I just used some wick to clean it up. And then I just go straight into attaching this other wire. For this next step, we need to look at a board scan. So first of all, this is the area of the board that I'm focusing on right now. This is the pin that we're currently working on, and this pin normally goes to this via. If we flip the board over on the other side, this is where it comes out. And following that down, it finally leads to this component here. So we need to somehow wrap the wire around the board and attach the end of it to this component. Ooh, freaking arm hurts. Please work. Oh, come on. Come on. Look at that. Okay. Boom. Whew. At this point, I decided to do a quick test to see if the trigger was working now. I knew that the joystick still wasn't going to work, but I was just too excited to see what would happen. Oh. Oh. Look at that. The trigger is working. Stick is obviously still broken, but the trigger is working. Nice. And now the the stick moves with the trigger, which, why would it be doing that? I actually never found out the answer to that, but either way, I moved on to the joystick area there was this one area here where there was a pad on one of the pins that was completely ripped off, so I had to reconnect it to this trace right here. But first I had to scrape off some of the solder mask on the board, which I just did using my X-Acto knife. First I add some more solder to this pin, and then I just attach the wire. I found it pretty difficult to get solder to stick to this little trace here, but eventually I got it. So while I was working on the other side of the board earlier, I noticed that there was a small crack going through some of the traces. And that's super close to the left joystick area. So I'm thinking this actually has a lot to do with the joystick problems. So I'm just going to scrape off some of the solder mask and just apply more solder, and it should restore all those connections and everything should be working fine. And actually, after seeing this crack, I started to form a theory of what originally happened with this controller. So I'm thinking the original owner probably dropped it right on the left stick, hard enough to crack the board, and suddenly the stick stops working. So he probably opened the board, thought it was the stick, tried to replace it, ended up burning everything, and then just decided to sell it. So, which I totally understand, because this type of repair really isn't feasible if you don't have the right equipment for it. I was so excited to test the controller now that I forgot to switch scenes. So you'll have to watch this screen while you listen to my reaction.
Oh, no way. I've done it. I've done it. Yes. Yes. Woo.
So I'd still like to go back and clean up a lot of the joints and clean the board a little bit more with some isopropyl alcohol. I definitely would never sell or use this controller until I could get some solder mask to cover those bridge connections and a lot of those exposed traces and pads and all that. But that's just more equipment that I need to buy, and I feel like lately I've been buying way too much equipment, so that's about all I'm going to do for now, and yeah, I hope you enjoyed watching.